Aviation is no longer a luxury like it used to be 60 years ago. It now is a means of mass transportation. It's never been easier and cheaper to fly, and this is because aviation has been growing exponentially in the past decades. And this growth is going to continue, at least in the next 10 years, for 5% per year. Even though this is great for me and my colleagues because it means more work in the future years, it's not so great for the environment. Did you know that currently, by itself, aviation accounts for about 4% of the total greenhouse gas emission around the world? And if we don't do anything with this expected growth in the next 10 years, the environmental impact of aviation can worsen by more than 50% in just a single decade. This is something very concerning. This is why, together with other scientists around the world, we've been looking into ways to minimize the fuel consumption of airplanes. And one potential solution to this issue may actually not be in engineering, but we can find in nature by observing birds. Birds are the most efficient flying vehicles we know because they can continuously adapt their shape of the wings during flight, and they do this because they're flexible. And by doing this, they minimize the amount of energy they require to sustain flight. This is why they can be very fast and agile when they need to, for example, for fishing, but at the same time, could sustain flights that last for thousands of kilometers without stopping. Imagine non-stop migrations from Alaska to New Zealand, for example. On the other hand, airplanes, like we know them today, or like the ones you see in Bristol Airport, they do change shape of wings during flight. They have a series of panels that are hinged to the wings that move up and down. We call them ailerons, elevator, rudder, etc. And these panels, when they move, they allow pilots to control the airplane. However, the change in shape doesn't happen like in birds, because it happens in a rigid, discrete, sudden, and discontinuous way. And when they deflect, they leave gaps in the surface of the wing. And these gaps increase the drag of the vehicle, which is the air friction. And more drag means higher fuel consumption and more noise. This is why in my PhD, we're looking at a different approach. What if we instead design a wing that is flexible enough that can deform in a large, smooth, and continuous way without leaving any gaps in the surface of the wing, like birds do, or like the one you see here in my slide? That's the concept I work with, and we can get those large and smooth deflections because we combine very strong and stiff materials, like carbon fiber, in the inner skeleton of the wing, with very compliant ones and elastic, like rubber, in the outer skin. Because we pair these two materials, then we can get large deflections without actually sacrificing the safety of our structure. Hopefully, by the end of my PhD, we'll be one step closer to airplanes that fly more like birds. They're flexible, they can adapt shape during flight, produce less noise, consume less fuel, which is not just great for the environment, but also for you, because lower fuel consumption would mean cheaper airplane tickets, as airlines will have to spend less money running airplanes. Thank you very much.